Okay, so next wee bit is exponentials. So again, I'm going to show you exponential functions. The way of using it by substitution. And then the way I would do it, that's the root. So that's the power of a half. Okay, remember power to power means multiply, so that's just the same as a half x. Again, I keep finding this so hard to do because I normally just do it the second method. So let u equal the awkward bit. So differentiate that. So to differentiate an e, I'll just remind you on how to do that. Is that better there? So if you've got an e function, and if you differentiate it, the derivative goes in front, and you multiply it by the function itself. That's how you differentiate. So I've got to differentiate this e. So the derivative of x is a 1, and write down the function. So that's just me just using that wee rule there. This comes up to dx, and you want the dx on its own to substitute in there. Ex equals dx. So I'll call this equation 1. So equation 1 becomes the integral ex, your ex is now u, so it's u to the half, dx is this, ex is u. There's a reason I don't like this method. U a half over u1. You subtract the powers, you get u to the minus a half. Finally, I can integrate it. Add 1, divide by it, and don't, oh, I have intervals here, integrals, no dear. So it's 0 and 2, makes it even more complicated. So that's x is 0, x is 2. So when you're down here, x is 2, x is 0. So that dividing by a fraction is upside down, so that's 2 the square root of u. You can't substitute your x limits in, so either rewrite this in terms of x's or rewrite this in terms of u's. Easiest for me just to rewrite this in terms of x, because u is e to the x. Now, sub in your 2, so it's 2 root e squared minus, then sub in your 0, e 0. That gives me 2, the square and the root cancel off, and the power of 0 is 1. So it's 2e minus 2. Goodness, that was very complicated for that. Okay, this is the way I would do it. So it's e a half x dx. Now, I have to think to myself, I like doing it backwards here. So, how do you differentiate an e? The derivative must be in front. So again, I must have the derivative. That's my key. So the key is derivative in front. The derivative of this is a half. So I'm going to put a half in front. I've got the balance outside by a 2, because the 2 and the half will cancel each other out. Once I've got my derivative in place, it's just working backwards. So when you differentiate an e function, derivative and the e function. When you integrate it back again, the derivative will disappear and the e function will just stay the same. So that's e to the half x. That wee 2 just sits there. Your limits and all are fine here. So you get x to 2 and x to 0. So that big 2 just sits outside it. Sub in 2. Half times 2 is 1. Sub in 0. E to the 0 is 1. There you go, straight off. 2e minus 2. I think it's a little bit easier that way. But again, the choice is yours. I think we'll do the log function at the same time because that's quite similar. Okay, so example 4, part 1. Just check there's not too many questions on this, not just the one. Right, the horrible way. 1 over 2x add 1 dx. If you brought that up as a bracket, the bracket would be minus 1. And if you added 1 to that, you get 0, and the whole thing collapses, so you can't bring that up. So, by substitution, u equals the awkward bit. I need to do du by dx, differentiate that, rearrange it to get dx on its own. So it's a half du equals dx. So rewrite your integral as 1 over 2x add 1. Your dx is a half du. Remember, this is now u. So it's 1 over u times 1 over 2. So it's, bring your u up. So it's a half u to the minus 1 du. If you add 1 to that power and divide by it, it's collapsed. So that is absolutely no good to you. You can see why I hate substitution. My way of doing that one. Okay, the trick there was the word log at the start. Do you remember how you differentiate a log? Let me remind you. If you had a function like that and you were differentiating it, the derivative went on top and the function went beneath. That was differentiating. So if I'm going backwards, if I've got the derivative on top, so if you look at this here wee function I have, see if I had the derivative on top of that, that would integrate back to log the bottom line. Okay, so I just put that 2 up there, didn't I? Just wanted the derivative up there. I forgot to balance. So just put your wee half outside. That's it done. So I'll give you a few wee notes there. The key is the derivative on top. And you balance outside. So balance outside is normal. And then it goes back to a log function. Log or ln. Tend to use ln. Right, how do you recognise those? If you have an x expression in the bottom and it's not in terms of a bracket, it's going to be a log. So when I look straight at that, I know it's going to go back to the log. I need the derivative on top, so the derivative is 2. I put a 2 on top, I balance outside. This all disappears back to the log. And don't forget your C. Now I have made one wee error here which I'm going to explain to you now. If you try in your calculator for a log of a negative number, like say -5, it comes up an error. So you never leave your log as brackets. You write it using the modulus sign. And that means it's always log of the positive. So I've always just tried to get that in there. And yeah, that's that one.